Hello, I'm David Keith. I grew up in Ottawa, Canada, where I had a lucky break when I got to visit Paul Corcom's laser physics lab and ended up getting hired as a summer student in grade 11. It was life transforming. By luck, I'd wandered into the laboratory of one of Canada's best physicists. And at that point, Paul still had time to mentor a precocious high school student. I got my hands dirty playing around with equipment that most physicists don't get to use until graduate school. Electronics, optics, machine shop, high voltages. It was heaven. I then went to the University of Toronto in physics, but in fact I ended up taking a lot of courses in philosophy, in part because the teachers there seemed much better than the teachers in physics. I left undergraduate somewhat disillusioned and spent a year mostly outside as a climbing bum and on long wilderness trips, working as a field assistant in the high Arctic. I still do a lot of climbing, rock and ice, as well as wilderness travel. I was lucky enough to get into MIT for grad school and was a student of Dave Pritchard, where I helped to build the world's first interferometer for atoms. This was a hot project in the physics world, and I loved it. But by the end, I realized I was more interested in working on problems that had some real-world direct impact. I fell into a group of graduate students, a self-organized group, with interests that went far beyond their professors. Lesson: don't be afraid to pull off in your own direction. Professors are often teaching you how to fight the last war. And through that group, I became exposed to all aspects of climate change, from science to energy technology and public policy. In more than 25 years since then, I've wandered back and forth between work on energy technology, on climate science, and on the related public policy. I did a postdoc at the National Center for Atmospheric Research, and then at Harvard, where I developed an instrument to make accurate measurements of the Earth's temperature from space. Amazingly, we don't really do that. We never got it flying on a satellite, but we did get it to above 70,000 feet on NASA's ER-2 aircraft. For many years, I worked with people in the Department of Engineering and Public Policy at Carnegie Mellon, which has one of the best programs doing technically rich, policy-relevant analysis of energy systems. Much of the thinking in this class derives from my experience with colleagues at CMU. I then went back to Canada, to Calgary, in the heart of Canada's oil patch, one of the more important oil cities in the world. For just over a decade, I worked to build up an interdisciplinary energy and environmental systems center at the University of Calgary. That effort ultimately failed, but in the process, I learned a lot about how the energy industry works. While I would certainly vote to impose high carbon prices that would crush the fossil fuel industry, and while I know that some in the industry have spread disinformation to block climate policy, indeed I have personal experience of it, while at University of Calgary, I was a victim of some of this and ended up helping to blow the whistle on corruption of university research by oil money. But even so, I'm distrustful of the easy overconfidence of many in the environmental left, many of my colleagues here in Cambridge, Massachusetts, who imagine that everybody associated with the fossil fuel industry is somehow dirty or corrupt, and that we can easily transition to a cleaner future if not for political opposition. I don't think the transition will be easy. I don't think it's just political opposition that blocks it. I have no doubt that we can and will get to a high-energy, carbon-free future. But I share some of the skepticism of folks in the oil industry who doubt claims about the ease of transitioning to renewable energy. And I don't think the level of commitment to public good or even the environment is much different between Oil Patch Calgary and University Patch Cambridge. We're all living on this planet together. While in Calgary, I founded Carbon Engineering, a startup company developing technology to capture carbon dioxide from ambient air, with the goal of making high energy density, carbon neutral transportation fuels from low carbon power sources such as solar power or nuclear, as a way to power heavy transportation, like aircraft, in a carbon constrained world. At Harvard, the main focus of my work is solar geoengineering, the idea that humanity might be able to deliberately introduce some reflective particles into the atmosphere to reflect away a little bit of sunlight and offset some of the risk of accumulating carbon dioxide. If this makes sense at all, it is a supplement to emissions cuts, not a substitute. In the long run, we have to cut emissions if we want a stable climate. This course will deal entirely with emissions and their consequences, not with solar geoengineering. But it's important to know that that's one of the main things I work on day to day. Finally, I've been lucky enough to travel to some of the poorest and most polluted places on the planet. And this has helped me think about the pressing need for access to clean energy among the world's poorest billions. The magnitude of environmental risks from air and water pollution today and the gradual buildup of carbon dioxide that will change the climate and put some coastal cities underwater this century. These are huge problems. We must find ways to solve them.